Welcome to the last of the 2023 Science on Saturday lectures. This is one that I know, right? And before we get started, and most of you have been here many times before, but my name's Andrew Zwicker. I get the privilege of being the host to all these lectures. But because this is the last one, I have to do a bunch of thank yous because, as you know, this has been our first time back in person after a 3-year break. And to see everybody here in the auditorium, and a big shout out to those who are around New Jersey, around the country, and we have people from around the world watching online at this point. It's so good to see everybody back. But this was the first public event this laboratory had done in 3 years, our very first lecture. And so you were in many ways the part of our experiment to get back. And so thanks have to go to so many places. So a couple of our ESU folks are in the back. I just want to give them a shout out for getting everyone through the gate. Our facilities, site protection, custodial staff have just been awesome. Our audio, thank you. Our audio-visual folks, Harry and Anthony, big shout out. Anthony's in the back today. They alternate. He's waving. And of course, everybody in science education, where's Arturo's right here, Arturo Dominguez, who's the head of science education. But the two people who I did not let leave, because normally they would go and finish up, everything has to happen here. But you should know that just a couple of days ago, we did the Young Women's Conference in STEM, in science, technology, engineering, and math. 800 young future scientists were on campus. Amazing thing organized by these two people. At the same time, as you know, we did the Science Bowl quiz competition, where we had hundreds of people here yet again. And of course, these lectures, which just happen, you know, it looks so smooth, but it doesn't happen without these two people right here. So to Britt and to Dee Dee, thank you so much. Oh, and then the last one, and I really mean this, is to each of you, because coming together because you love science, because you're curious, because you're a lifelong learner, whether you are 8 or 80 or anywhere in between, is just so inspiring. It is an unbelievable privilege to stand in front of you every single Saturday and celebrate science, which is what we're going to do today as we talk about science and we talk about art and we talk about fashion. But in the end, we're celebrating curiosity. So I would very much like to give each of you a big round of applause. And so today is a conversation, and just beyond thrilled to have Gabriela Hearst and Alex Creely here. As you can see on the screen, Gabriela is an award-winning designer who's dedicated her spring-summer 2023 collection for the French Maison Chloé to creating awareness around fusion energy, which is just unbelievable. And Alex is a scientist and engineer, and I love that, on a quest for clean energy, as we all are, and is the head of Tokamak operations at Commonwealth Fusion Systems. For those of you who were here last week, Devin is Alex's colleague who gave us the overview of fusion, what's happening at Commonwealth. So we tie it all together in today's conversation. But with that, let me stop sharing the screen so that we can, or can you do that? Anthony, can you stop sharing the screen? There we go. And would you please now welcome to the Science and Saturday stage, Gabriela Hearst and Alex Creely. You don't have mics. It won't be a conversation without microphones. I think you have to turn.
Hi. There.
Okay. So as you saw, this is going to be a different type of Science on Saturday. It's very much a conversation between the two of them about the intersection of science the intersection of art. But of course, I warn them that they don't get out of the three questions. In fact, they're going to play off of that to get the conversation started. So first question goes to you. And first of all, thank you so much for coming down today to this. But tell us a little bit about your background and a little bit, of course, of how you even got interested in science. So you're not a scientist. And then we'll ask the same question of Alex afterwards.
So I'm from Uruguay, South America. I grew up in a ranch, seventh generation rancher, and my family have had pre-industrial practices. So basically, I learned about sustainability from a utilitarian aspect. And in a very remote place, I form my aesthetics based on gaucho tradition and my education. And I would say that I was one of those people that was extremely curious, didn't really know what they were going to do. And I was trial and error. And I knew it was something in the creative field. And I guess that fashion was the one thing that I was kind of good at from the start. So, and that's, 2 decades of working on that. But how I got interested in fusion comes from, well, 2 things. I've said, and it was in my presentation when I did my presentation for Chloe, I truly believe that is the creatives and the scientists that will take us out from where we are today in the predicament that we are today. So in my vision, I have a neo-renaissance where these 2 disciplines live together. And I don't think that the scientific mind and the creative mind are very different. I think that's more of a optical. I think the scientific process is as messy as the creative process. It just gets out in a clean paper, but they're very similar.
Same question to you, Alex.
Yeah, sure. So I grew up in Missouri, but have always been very interested in the outdoors, was in the scouting program when I was younger, did a lot of hiking, a lot of camping, and was always good at just like building things in the backyard, building Legos, building all this stuff. And by the time I was going to university, I knew I wanted to do something technical, like some kind of engineering. And I knew I wanted to work on clean energy because I loved the outdoors. I loved being in the outdoors, and I wanted to like have that be around for the rest of my life, and then for the rest of the next generation and the generation after that. So I got into clean energy. I did my bachelor's at Princeton, so just down the road, and had the great fortune my freshman year of coming on a tour of PPPL. It was offered to freshmen as a thing, I think on Parents Weekend or something. I didn't know about fusion before that, and came here and was just, this is awesome. This is like this clean energy solution that I've been looking for. And have got into fusion, got into science, and somehow ended up back on the stage here today.
Full circle. So actually we'll go to you for the next part of the 3 questions. Tell the audience about a teacher who was influential at any point from being a little kid on up to the last couple of years.
Sure. So my PhD advisor during grad school, so I did my PhD at MIT after my bachelor's here. Ann White, Professor Ann White, she is now the head of the Department of Nuclear Engineering and is going on to be associate provost at MIT. Incredible teacher. I think that the thing that really struck me was that she's an amazing scientist. She does really good science, but she also deeply cares about her students. And I think it's that personal caring where it's, she's not teaching in order to further her own career or even to further science, but it's to train the next generation of students. And I chose to go to MIT, not to go to MIT, but in order to work with Ann White. And I think in retrospect, that was 100% the right choice. I really, really appreciate everything that she gave to her students, to me and to the students she has now and to students who have in the future. And so I think, where I am in fusion now started at PPPL, but the scientist I am today, I think I really have to thank Ann White for.
I love that. So same question, a teacher for you.
Well, I think I would say Mrs. Simon, my art teacher at the British schools in Montevideo. I remember she used to teach us to draw patterns and learn patterns. And I think my brain has formed in that way that I can associate ideas quite quickly because I was drawing these patterns when I was a kid. So I would say Mrs. Simon.
So, all right, last question, and then we'll get into the heart of everything. So, something in your case, when you're not designing, when you're, not fashion, but a hobby or an other interest.
Well, I would call them passions, not hobby. And I would say that fusion has taken a good part of my focus since 2021, since the late part of 2021. As for someone that had cared about sustainability and trying to think about solutions for climate success, how I would like to call it, fusion felt for me like I fell into the holy grail. And when I look at the eyes of people that work in fusion, I see a lot of hope. So that's where I'm serving right now.
It's so true, right? When you work on a project that's 70 years in the making, you have to be an eternal optimist, of course, but it's the grand challenge. Alex, same to you.
Yeah, I was emphasize the last point that fusion being a source of hope, I think, is an incredibly powerful emotion in today's world. It's a big part for me as well. But yeah, to answer the question, so I still love the outdoors. So I still go hiking and camping and biking in the outdoors. I also do ballroom dance, which we were speaking about earlier. So maybe my closest in my previous life, my closest exposure to the fashion world was in the ballroom dance world. So competitively did waltz, tango, foxtrot, Viennese waltz, and quick step, cha-cha, samba, rumba, jive, and paso doble.
I'm just gonna give a tip here for the single, right? He met his fiance that he got engaged 2 days ago in the ballroom.
Thank you.
So maybe you want to try ballroom instead of an app. Just saying.
Best advice.
Good advice.
So Anthony, we're gonna queue up a video, but maybe you can before as we're queuing it up. Don't play it just yet, but you could tell us what we're about to see. It's about a 2.5-minute video.
Yes, we're gonna watch the Chloe Fusion show that we use an incredible light designer called Paolo Montiel that works with James Turrell, the artist, and he created these rings with the shape of the tokamak. And it was really I remember telling my creative team at Chloe, well, we're going to do fusion this season as part of the clean energy, because I'll tell you when we have a moment of how I see the 4 chapters. And I could see the face of my team going like, fusion food? Fusion what? And that's the first thing people say is fusion food. And fusion music, I'm like, no, clean energy, the reason you exist. And so I told them, I promise you that at the end of the journey, you will be able to talk about one of the big solutions for clean energy that's scalable. And so this is the show about it.
So Alex, if you could hit play, and it's got sound as well. Turn it up.
There were some isotopes there if you would see them.
So first of all, before we get into that, I'm going to say every plasma physicist or anyone who studies the light that comes out of tokamak instantly got the colors that you chose, which was just remarkable. So that was amazing. Okay. I don't even know where to go with all of that. I mean,
The first thing in my mind was like, we should dress all the scientists like this. That's how,
wait,
right?
have you seen how scientists dress?
I'm here to help.
I'm wearing Chloe and Gabriela Hearst. So I had some help this morning.
Then you are clearly the best dressed plasma scientist there is out there. I guess, there was so much in that video, from the color to some of the patterns. Where do you want to start with your inspiration for that?
Well, I think that we went in this journey with the team, and I am so grateful that the Chloe team embraced it, right? Because it's a challenge, and they did. And we went to ITER, and we went to Commonwealth Fusion, and we visited Helium, and we studied some of we knew the color through JET, and we've tried to look at everything we capture. And one of the things is I did all my research first reading, but then it's when you visit the sites and you start to like really look at everything. And so we took bits of it, and then we created the isotopes on the denim dresses, like a bit of an abstraction. And take it from there. But that's where our job came, and we had real glass blown interpretations of the isotopes and as decorations of the dresses. And it was a true journey. And it's because of the process, I have to move on to the other collection. So I have a kind of a system in me that it's done, and I don't really look back to it. And then when I was looking at the show, I was like, damn, that was a good collection.
So how'd you meet Alex? How did that start?
In the research, we met at CFS, and I have weaknesses for really bright people. So here we are.
So Alex, here comes this person. First of all, did you have any idea who Gabriela was?
I will admit I did not.
Right.
I did not, but my fiance did. She was very excited.
Right. And, what did you think when it was like, hey, I'm interested in learning more about the science, and why did you jump at this?
I just generically, I think the more people that are interested in science, the more people that learn about science, like the better it is for the world. People understanding what's going on in the world around them, people understanding clean energy, so people are excited about it rather than scared about it. Like anyone who's excited about it is I'm always happy to talk to. And go for it. Yeah. And so I think like anyone reaching out, I'm always happy to talk. And I think so I didn't know too much what to expect when I heard that a team from Chloe was coming to visit CFS, but I was, always excited to talk to new people, always excited to talk about fusion.
I think my real drive at the time when I started, I got excited that the private sector was getting excited about fusion. And so I was very interested to study both the private sector and the public sector, because I really think that the success of the mission is in the alliance of both. And for me, I saw that, I think that, let's say, fission has maybe a PR problem, right? But what fusion had was a communication bridge. And so the idea of cross-pollination, because we live in this silo information, right? Where the fusion world is going to know about the fusion world, and it's not going to really diverge from other publications. So the fact that we got a Vanity Fair article on it, which was incredible. So the idea of cross-pollinating, and it's just exactly what Alex said, of having more minds knowing, hey, hold on, there's good news, right? There's good news. They're coming. There's good news.
There's hope.
Yeah. And in this day and age, good news don't sell as much. So that's really was one of the driving missions, as he said, to get more people to know about it.
And I'll say I was, always talking to people about fusion, and Gabby was the best informed person who has ever come to talk to CFS. You asked amazing technical questions right from the beginning, asked about magnets, asked about Spark, asked about our timelines. So really did her homework.
So I will say, it was my friend Bill, who's in the audience right now, who emailed me the Vanity Fair article. And I was so excited because here is fusion and fashion, or the fusion combined, in Vanity Fair. And so it was just an email that started this whole, like, would you come here to talk to this audience? And to be honest, I thought I'd never get a reply back, and your team jumped at it. And so beyond thrilled that that article led to, and there's a picture of you, I guess, at Eater. Oh, there it is right there. So that's in the south of France, as we heard last week, right? It's the largest machine ever built. And you said something else really important, and Eater is relevant to it, as is CFS, right? So that machine is built by government dollars. CFS is being built predominantly with private dollars. And now we're combining, in some ways, the two. So could you go back and a little bit more from your perspective, why you think that's so important and how that was part of your thought process as you're going into this?
When I have Arnaud here in the audience. I know we're in October 2021 when I was reading an article in the Financial Times, and then I started to research more, and I'm like, this is it. Because I'm like, this is like, all of a sudden there's like 35 companies in the private sector. And I quickly, talking to Alan from your board, I really understand that this is energy is a scale issue. And this is a scale solution. So even if just from that point of view, it felt very excited. But I know that the momentum had kind of stopped in 2000s. Like if you see the graph of growth on fusion, it was pretty steady from going up and up and up, and it kind of stalled. And now the momentum started to feel right. And you can see in the 1 year that I since the beginning of last year till the end of last year, people were like, is it really happening? What is it? And then now more people know. And so I think we're facing the jump and the financial, people say, are you invested in fusion? I'm like, I don't have that type of money. it's like, yeah, I wish I'll do anything for fusion, but I'm doing it because I really believe it's a hope for us all to exist.
I just love that. So let's go into some of the creative thoughts now that, the video showed pieces of it, and, you could see, as you talked about isotopes, there were rings of light that to me remind me of hydrogen plasma, right? So how did you start to, as you go from research, you start talking to people, but let's go into that creative process to both the lighting, but of course then into the fashion itself.
All right, so this is like a case of typical Gabby moment where I said, I need the best light designer. And I went to raves. I as a, middle-aged 40s, went to a rave for the first time in my life. I understand what a disco nap is because at 2 o'clock, it's like, I have to go home. But I was like, I need to find the best light designer in the world. And somebody told me, Paolo Montiel, but he's really won't work with you. It's just like, I'm like, get me his number. And I'm like, hola, Paolo. He's from Mexico. Hola, Paolo. I have this idea about fusion. And he's like, I study physics. Yes. It took like 2 minutes to get him on board. And he jumped, and you were in a call with him. And the idea was to put Paolo with Alex together. So,
and so we had a meeting with a team from Chloe and Gabby and Paolo, and we talked about diagnostics and all the light that would come off and the Balmer Alpha series and the various aspects of the lights and the sounds and the vision that you'd see running a tokamak or running another type of fusion experiment, and pulled up a bunch of pictures. I think tried to get him the inspiration that he would need to lead to something like this.
And just so you both know, we handed out little diffraction gratings, many of you have seen, which takes white light and breaks it up into the colors of the spectrum of the rainbow, if you will. And so you can look up into the lights and see the rainbow there. But at the same time, maybe Alex, just a little bit more, you said it very quickly. You talked about light. So tell us a little bit more about the light that comes out of a plasma.
Yeah, so there's a wide range. And I think one of the most interesting thing is that if you look at a tokamak plasma, the middle of the plasma, you can't see anything. And that's because the plasma there is so hot that it doesn't emit visible light. It emits, higher frequency light. And so you only kind of see this like ring around the edge of the plasma, and that's where it's cold, only 10,000 degrees, only 100,000 degrees, not 100 million. And that's where you get this, the visible light. And you will often get kind of a nice pink glow, or depending on the gas that's in there, the plasma that's in there, you'll get blue, or you can get some purple. And so that's, pink is a lot from the hydrogen. So I think some of that inspiration was here. You can see there are some earlier pictures of a nice pink glow coming out of a tokamak. And that's all from the electrons inside the atoms at the very edge of the plasma moving around, and giving off light as a absorb heat and give off light, and absorb heat and give off light. So you get this like really cool spectrum. It looks nice, but also you can measure that with, I say fancy thermometers, and that you can tell what's going on in the plasma based on the light, based on how much, based on the color, which is one of the cool aspects of tokamaks.
I mean, in many ways, everything we know about the universe comes from the electromagnetic radiation that reaches Earth, whether it's visible or X-ray or infrared or anything in between. And so we can do the same thing of light that comes out of a fusion plasma. So there was another one that, besides the color, that showed that one, the rings. And you said it quickly before. So those rings aren't just arbitrary either.
No, they have the tokamak formation. And so Paolo really measured those rings. It was the concept of abstraction, because we really focus as the tokamak as the device, because we do believe, like CFS, I do believe personally, that this would be the technology. But whoever does it, we're all happy. But what you were saying too, when you were just one of the things that attracts me so much about it is that I found, and Alex knows this because I told it to him, I found physics so poetic. There's something really truly poetic about understanding physics, and from a creative mind, it really inspires me. Just to know how small we are, but how special we are at the same time, and it's really beautiful. It's an incredible journey that I just keep on wanting to learn more. And with sound, because I was like curious about what's the sound on a tokamak, and there's really not much sound except some
machinery around.
The machinery around. So that's where we had more creative kind of, let's imagine, and I work with an amazing group of music producers from Uruguay that we created the music.
So if you as a fashion designer think of physics as poetic, then Alex, what do you as a physicist think about fashion design?
Yeah, well, I think one of the really exciting parts about going to the show was to see all of the little details that had this, this real great inspiration that you could find looking back to some aspect of fusion or some aspect of the tokamak. So, on these images here, you can see the colors, those ones are, very apparent. But I think on the far right, you can see the isotopes. So there's like these riveted in deuterium and tritium atoms with like 2 or 3 dots in the middle. And I think one of the ones I found really cool was there's not image here, but there is a dress with clasps that were inspired by like different magnets and stuff on the ITER tokamak, or the little blown glass beads. They look like a spherical tokamak because it's a little like metal pin through this like glass porous. So I think for me, it's that the little details that you maybe don't see initially, but you zoom in and you're like, wow, a lot of thought was put into this little piece. And you trace that back to physics, and like in physics, often it's the same thing of like, the real great inspiration is like, wow, how did they see this little detail in this like big cloud? And so it's a similar idea of like finding this like little, little piece of beauty or this little piece of inspiration in this big picture.
Well, so first of all, some of you may know, but PPL's main machine is a spherical torus. And so to know that part of your design includes spherical torus, of course, now we're going to have to make sure our director is aware of that and purchases, I don't know if it's a dress or whatever it might be. So tell us, I guess, Gabby, tell us, about the images that we're seeing right now and some of the details and some of your thoughts as you were going from research to now final product.
So yeah, we, as Alex said, we went macro and micro, and what you're seeing right there is like the fuchsia for the plasma, and then for the plasma night, and then those denim pieces is actually what it's something I'm really, really proud of, because it's not regular denim. I don't like using cotton because of the monocrop and the herbicides, pesticide situation when it's organic, and also the water wastage that goes into cotton. But those are made out of recycled cotton. 85%, 87%, and 30% hemp. So it took us years to develop this material. So it's basically what you're seeing is waste, but we made it look beautiful, which I do believe that that's where we are moving in fashion. And this is what I've tried to do since we started, to really show people that we can use what's already in existence. So we give an environment a little bit of a rest. And so this is, and then you see the isotopes, the deuterium and tritium in the rivets, and the glass that he was talking about, those glass beads, those are hand blown in France. So there's a lot of craft that goes in the idea of the human hand and the machine together. It's really special, right? Because there's certain things still that a machine cannot do that a human hand can do.
And that level of detail is so remarkable. It also reminds me of, in many ways, the level of detail that goes into designing not just a fusion reactor, but Alex said it quickly, like a diagnostic, as we try to understand even what's happening, the level of detail that goes into a diagnostic. So I'm going to turn it over to you, Alex. Like, talk a little bit about the design process as a physicist to make a measurement, let's say, of light that's coming out of a tokamak.
Yeah, sure. So the background there a little bit is for my PhD thesis. I like to say I built fancy thermometers, but it was a diagnostic called correlation electron cyclotron emission. So it collected light that came out of the tokamak, and you looked at light really close to each other, and you could tell the temperature of the plasma. And then with that, you could look at tiny little fluctuations in the temperature and see turbulence. So you could see turbulence in the plasma and understand what was going on, how it was moving around, how it was transporting heat. And so I think that, as you try to measure something, you'll look, there's a big chain from what is the thing you want to measure? And then you think, well, how does that manifest? How does that come out? So I think, if you have a thermometer, you can see, well, you have a little piece of alcohol, little red fluid in the thermometer, that it expands if it gets hot. Okay, well, I can use that property to measure something. And so for plasma diagnostics, it's the same thing. You think of the thing you want to measure, you think of how that manifests in the real world, like something that you can look at. You start thinking, okay, well, how does that manifest? How can I measure that thing that it manifests? And then you design a whole machine around it. Often it's, very, very small details are going to matter, like how the data comes out. And then, you build it, you test it. It probably doesn't work the first time. You change it a little bit, you test it again, and you eventually get out this measurement that you were trying to make at the beginning.
So science is really about failure, right? Because we fail more often than we succeed. But of course, we're always striving for success. And I love what you said about the fact that, we sometimes don't get it right, or there are error bars, we're not quite certain, and we're trying to shrink that down. So same sort of question, right? How do you, number one, do you fail? How do you define failure?
Oh, I love it. No. Oh my God. No. I think failure is, you build success on failure. So when you just said science it's a metaphor for life. I fell into fashion for failing until or what people measure as failure, right? But I think that it is the equation in order to succeed. I look at even my fashion career in the same way, or a creative process, and is the same way. And sometimes it's a good idea and it gets executed, and we have very short. It's like when I try to explain people, or I collaborate with musicians for our show, and it's you work on an album for 2 years, you work on a talk about for decades, and we work in 6 window periods. So we work really, really hard for something that lasts a couple of minutes in a show. So it's like more like building a mandala in a way. And so sometimes it's like you're doing something and the timeline it's not going to meet. And sometimes it's a good idea and you're like, I'm going to hold on this too and evolve it. So yes, we are also built on failing.
Okay, so let's go a little bit further, because in science, we know failure. We know how to, it's very precise because we're trying to measure something very precise. But what you're doing is part of your creative process. So how do you know whether it's something isn't working, or how do you know when that's it?
Well, I'm in a business, right? Numbers. Sell-throughs. I always say that my self-esteem is based on sell-throughs. It's like, it's a business. So you're proven on a lot of things have to be on the ground. And when you get a hit, when you get a hit, like the Nama's a hit. And we worked I'm really proud of this sneaker. I mean, it's a product placement now.
I don't know if the people in the back, hold on. You might as well, right? Can you see Alex's sneakers?
This is the example of group effort. We worked 8 months on this sneaker. It's made out of recycled material. We had a third party analyzed it, and it saves 80% more water than the previous sneaker and produces 35% greenhouse gases than the previous sneakers that they had. And we put out a product. So I had this theory with the team at Chloe of let's change the volume drivers to lower impact, because how do you create growth in a company but lower the impact on biodiversity? So the NAMA was part of this mission, and you're hoping that it's going to work. But the first and foremost in our world, or in any other world, is not the good intentions that went behind it. It has to be cool. People are going to want to buy it and like it. And so then the number shows, and now it's the number 1 shoe at Chloe.
There you go. So before, I do want to open it up for questions of the audience, but you said something, Gabby, before that I want to come back to, which is you talked about fission and fusion, right? And if I remember correctly, you said fission has I think this is what you said, PR problem, but fusion has a communication problem. And so I'm curious if you could go, what do you mean by that?
I said communication bridge, which is better than problem, right? Because what it has, it needs, let's say, someone in fashion with high cheekbones to talk about it. And maybe we can get somebody from Hollywood to talk about it. And then we need somebody from another. So it needs people bridging, because in order for it to visualize us, I had very, very smart people that I deeply admire said to me, but is it really going to happen? I'm like, do the research. And it's the belief is there. There's so many positive aspects about fusion that I can just sit down here for 5 minutes and tell you why this needs to exist right now. And so that's why fusion needs more people talking about it and more presence. And this is why I'm just like, all my sustainability efforts are going to this right now in that sense. So
first of all, I love that. And I'm profoundly grateful for that as a fusion person. I don't know if you know, some people may remember this, but Priuses, at least, became popular when I think it was Leonardo DiCaprio started driving it. Of course, the flip side is Arnold Schwarzenegger was driving a Hummer around the same time. right? And the profound influence. And so the audience
We're
members,
hammers now.
yeah, they're getting electric, right? Nothing like drive an electric Hummer, save the earth. Somehow that doesn't quite work. But what you have done is bring in an audience that may not pay any attention to fusion, right? In your work. And by doing that, you know, who knows who's been sparked to continue to talk about it, which, you know, we may never find out, but from your clothes, from your show, from your activism is just, you know, is so unbelievably remarkable. So before we open up, I just want to say thank you, number one, for that interest. You know, you just don't know. You just don't know.
Yeah. And I'll just add on that, like, you know, we, as a scientist, like, you know, I think a lot about the science of fusion and like, oh, if only we can solve this physics problem, like we'll be ready for clean energy. But like in reality, it's so much bigger than that. You know, CFS has brought in people from all these different industries, all these different professional backgrounds, and it's engineering, it's finance, it's the business model. You know, if we don't build a lot of fusion power plants, we're not gonna do much. And it's the acceptance of people knowing about it. It's politics. You know, this is not just a technical challenge. It's a societal challenge where we need, you know, everyone doing what they do best in these very, very different like walks of life and these very different fields to make it successful.
If only there was a politician who liked fusion.
They're coming. They're coming. They're coming. They're coming. They're coming. They're coming.
So, Anthony, if you get microphones, oh, you've got them. Great. So last question before we turn it over to the audience. And this is very specific to, I can't ask Alex this question. I have to ask Gabby this question. When are we going to see fusion?
I have my canned response, but you shouldn't ask me.
I can't ask Alex this. When do you think, you know, with all your research, right? When do you think we're going to see fusion electricity on the grid?
So I'm like, I have hopes on these guys. So whatever they say their timeline is, I'm going to double down. But let's be clear. If we take the example of wind and solar, right? They had the deployment ready, like they had the proof that it could be done, but the deployment wasn't ready. So it has to be in parallel. There has to be people thinking fusion happened, and how are we going to commercialize it, and how we're going to. So I think the legislative process and the bureaucratic process has to be moving right now, like fusion happened. And so there has to be a part of it that is already thinking this happened. And so you guys do your job. And so that's basically it. And we don't have time. We don't have time. That's the point. It's like we can debate, but it's a need. Right now it's a need for survival. So I always get offended when people say, let's save the planet. I'm like, the environment and the planet will be fine. They will exist without us. It's like it's math, right? And so just, if you care for our species, right? If you think that there's something special about humans and we should exist and change, right? Because we cannot continue existing how we are. This is a chance, and we should all be betting on it hard. So for me, it needs to happen before 2030, like basically. So good luck, guys. Plasma physics is the hardest physics. I understand that.
Clearly, we need you in front of the Congress, and
I'm ready.
All right.
I'm working.
All right, we're going to go right now. So, okay. So why don't we open it up to some questions? If you just raise your hands, and we've got microphones ready to pass out. Questions on science, questions on fashion, questions on art, questions on fusion. There we go.
Hi. I must say I've loved this series, the science series, just as a heads up. My son is not here today, but he was so keen to be here. He's most likely going to be watching this recording. But I have two questions again. One is, you did speak a little bit about the material you used around clean energy sources for the denim. And I was looking at some of the clothing that came out, and I was wondering, what is the material, like how do you correlate the energy sources around, like clean energy sources around tying it with the material that you've used to build out and if you can elaborate on that. And the second thing is just an observation, but I had no idea that a fashion designer did so much more than just maybe sketching a diagram. So it is an absolute eye opener for me, and we really appreciate everything that you do.
Well, thank you so much. So I have a theory, right, where it's when it comes to fashion and constructing, I like looking at the past. When it comes to energy, let's look at the future. But if you think in Roman times, society was dressed with linen, wool, and leather. So I've tried to avoid, and I'm a rancher and merino sheep producer, so I understand the wool became like 2% of all the fibers used. Like merino wool, it's one of the most sustainable materials that you can use. And I stay away, as I said, from cotton because of the monocrop. So I choose linen instead because it absorbs, it wastes less water, and you can use linen also as a nutrient, flaxseed. So I love the resistance. And Steph is my witness here. A few years back, like around 7 years, linen is very accepted in Europe, but in America they find it scratchy because we like soft things here. We like comfort. And so I touched this linen by this male called Solviati that had treated aloe on it to soften the hand, but also it moisturized your skin. And I was like, oh my God, I am going to make sheets on this. I'm going to get pajamas on this. And it became the number one material. I get very excited with materials, as you can tell. And so that's, for example, one of my main materials is I don't use artificial materials unless they are recycled, like polyester, because people forget that, it's fossil fuel based. And so I use linen, wool, cashmere, recycled cashmere. Cashmere, if you're not really good at sourcing it, just to give you like just some ovine history here, the sheep are very good for arid regions because they eat grass close to the root. But the Mongolian cashmere, they take the root out. And so when cashmere became a boom and you can buy like a $10 cashmere scarf on Fifth Avenue, that has made the Gobi Desert, it has expanded the desert. So you have to be very careful of where you source your cashmere. So it's just knowing your materiality, which it's where most of my passion is. So for now, I am at a point that I really know what. I don't use viscose, for example, either because of trees, because even if it's a certified forest, it still takes a lot of energy to make a tree and a lot of water. So there's a lot of things I stay away from.
Yeah.
Thank you. Another question. I saw some hands up.
I have a question.
Go
It's
ahead.
me. Maybe I missed it. Sorry if I missed it when you said it earlier, or if you said it earlier. How did you connect with Chloe to collaborate on this particular line? And have you ever done anything similar with other brands?
To me.
So Gabby.
So I'm just going to take you a little bit into the madness of my process. The climate crisis, I have this process in myself that when something, and it's useful, so if you want to take it, use it. When something gives me anxiety, I write the opposite, right? So the climate crisis gives me anxiety. So I wrote down climate success because I'm deeply in this move. I was in 2017 in the drought in Africa, in the Horn of Africa, when they would save the children, because I knew what climate injustice was from a theoretical point of view. But one thing is when you see 20 million people at the risk of famine, and a mother that from Turkana, where we all come from there, that's the origin of humankind, having to choose of which child to survive, because I have to walk 15 kilometers to the tent clinic. So when you see that and you see the unfairness of it all, their livestock dying, the camels were dying in Somalia, and it wasn't making the news. So what the suffering that's going on through the tropics made me realize is that where we're living here are fiction. So my whole life is like, I can't just escape to Netflix or to the matcha latte. Like I have to do something. And so I really based it in 4 chapters, what climate success looks looks for me and what I can do with what I have, right? So the first one is what I believe in. The first chapter is the rehabilitation of the environment. There's going to be places we cannot commoditize anymore. We cannot commoditize the oceans. We cannot commoditize certain pieces of land because the earth can heal itself if we leave it the space to heal itself. That was number one. And I did my first show last February about that. Then the clean energy show, which was based on fusion, because we need clean energy. As long as this world is moving 80% on fossil fuels, we're doomed. That we know that. So we can talk about leather, no leather, this or this, straw, no straw. It's like we're doomed. Okay, we're doomed. And so clean energy now. And then 3, the empowerment of women, which is the show that I just did, because we need women in leadership position. It's just like you look at the numbers, you look at all this data based, it's you empower women, you empower communities, we are multipliers. And the 4th one is, which I'm going to do, is the change of consciousness. We need to realize that our brains are still functioning in the hunter and gathering days. And there's ways that we make choices that are not really favorable for our survival. So fusion was part of the clean energy chapter. And it really, as I said, it's the words going to continue. I want to see it happen in my lifetime.
So do we all. Question over here.
Hi, I was just wondering if you had like a favorite piece from the line.
It's always a hard question because it's like, basically, what child do you like more? But I would say that usually my favorite pieces of the lines are I love the Nama sneakers because of what it means. I'm very proud of the recycled denim because that's something that took us years to produce, and all the wool suiting that we do.
For my part, I also have favorite pieces, and they're not my children, so I'm allowed to have favorites. I love the fuchsia suit. It's just so bright, and I like bright colors. And I also really like the denim with the rivets. I think it's very subtle. That it's about fusion, but then you look at it and you're like, this is definitely about fusion. So that was I like that part too.
I love that part, that it's in the details, where to one person may just go, that's very pleasing to me. Another person may go, but that looks like a magnet, and it is because it's inspired by it, right? I love that intersection. Shameless plug, and I didn't mention this before, Princeton University in 2 weeks will open up its Art of Science competition, which is images created in the laboratory that are now being judged for their aesthetic value, right? Again, combining those two. Wow. So there's a question in the back.
Yes. So in science, of course, we evolve, for example, in plasma physics, we're evolving to get better and better, and so forth. I wonder, in the fashion or in the design process, do you quantify an evolution as to how much better one design is to the next, or something like that? Or how does that work?
Well, there's 2 variables to me, right? Of how I look at something. I have given myself as a designer that cares about the impact their product has, because I am making things people don't need, right? Nothing I make, it's a need. It's a luxury product. It's a desirable product. So if it needs to exist, it needs to be superiorly better than anything else that's out there, in sense of intrinsically in the materialities made, that it has a lower impact, and also in the social component of who's making this garment or who's making this piece. So that's for me the difference between something that looks good and feels good. But 80% of waste is it's chosen in the design table. So I feel that my creative process has been more about what do we not need? Like if you go to a Gabriela Hearst store, for example, there's no mannequins, there's no window displays, but it doesn't take out from your experience. So it's like, where is that fat that we can cut to make the experience what it is, but we just not being conscious, we just like put stuff in. So there's very different variables. So one is how it's made, who's making it, and the overall impact. And then beauty for me comes from the soul. So there, obviously that's the connection with the client. If that's, they feel that.
There's a question right there.
Hi. So I was wondering how you get like your everyday audience to understand the connection between fusion and like the fashion designs. Because like without knowing what it really is, it kind of just looks normal to most people.
How people connected fusion with fashion design?
Yeah, like how your audience would understand the connection between the fashion and what the science is behind that.
I would say that some didn't and some did. And I have to do these previews before for the reviews. And it was really, you were there for some of it. And so it was an interesting process because this was different than anything they've heard before. So it was very intriguing. But our communications team at Chloe has done a really good job at explaining as the collection hit the market and they started to, going to the website and asking questions. And for me, I'm like, if 10 more people know about fusion, it's already a win. If 20 more people knows about fusion, if 100 people, so it's like as much as we could push the mission forward.
In quantum mechanics, when you measure something, you change reality at some level on the quantum realm. So I'm curious. You said, okay, I did the show for people to review beforehand. Did you feel like once you explained and the communications team explained what the inspiration was, did that positive, negative change how people perceived and reviewed the show?
I think that, always it's easier to put yourself at risk to be criticized, right? But I mean, I don't care. It's my ego. I like the product. It's and the mission is more important. And I think the product was beautiful and it moved the dial. And then with the breakthrough that will happen in December, that was like, oh, she's not so crazy after all. So I think it worked. It was a great momentum. It just hit. The show was in September, and then you had a new awareness happen in December with a breakthrough. And actually I had people thinking about me. I got so many text messages from,
I think on top of that, like the articles in Vanity Fair or Vogue or the New York Times, where it's in a style section or a fashion section. So even if just like looking at the piece, maybe you don't know, like it's like the audience will read about it and will learn about it, and then we'll make those connections themselves.
It's true. We did the New York Times, Vogue, and Vanity Fair.
Women's Wear Daily.
Women's Wear Daily too.
We need fusion and science in those publications and sections all the time. So there's a question up there, and we'll get you a mic in a second.
First, I'd like to thank the two of you for pointing out the connections between something we don't think of as science and science. I think that was very enlightening. My question is about your fabrics, which you're using for luxury products. How scalable are those kinds of things you're doing with fabrics to a mass-produced, everyday kind of wearability?
Yeah, they're very scalable, especially when we talk about merino wool and we talk about recycled cotton. It's scalable. It's a matter of really deciding, do you want to have X amount of this or you want to have one, right? So it's about, I grew up with my mom in a ranch and her wardrobe was really small. She had a small wardrobe with a few pieces, and you didn't buy clothes every year. You bought clothes, every so many years and they were, she would do that with the seamstress and they were special pieces that then you would pass them down. So it was more about, you have your workwear that you wear every day in a ranch, which is not different from a cowboy wear. but you had those special pieces that I inherited from her. So it's about reducing your volume into more qualitative.
So we have a question here, and Arturo, if there's questions go here. Okay.
Yes, I was curious as to where these garments are made. Are they made in the US? Are they made offshore somewhere?
For Gabriela Hearst, we do both production in the US and in Italy, because since the Renaissance, I have to say the Italians are really good at craft. They're still the best gold casters in the world. And with Chloe, it's mostly European production and North African production too. We work with several non-for-profits and different trade fair. So I am someone that really believes is whoever can does the product well in with craft, because there's craft all over the world.
Friends of mine from Venice are online right now, so I'm sure they love what you just said.
They make the good shoes there, the Veneto area.
There's a question. Go ahead, up there.
Hi. Thank you both for the talk, by the way. It's been very interesting. And I have a few questions, if I may. I wanted to circle back to materials, specifically the polyester or any other fossil fuel-based material. I had read that every time they get washed, those plastics go into the waterways, which means the ocean and the buildup of plastic in the ocean. And then eventually, in the air and everywhere else, so that, it's all coming back into our bodies in an unhealthy way. And so I'm wondering about even using recycled fossil fuel-based materials. That concerns me. Another thing is in trying to build the awareness for the everyday public, because not everyone reads Vanity Fair, right? So, or other, even New York Times or whatever. Wouldn't the scalability downward to the masses, wouldn't that be sort of another version of a communication bridge for you?
The very interesting questions. Yes, the microplastics it's a real thing, and I use mostly natural materials. And when we use recycled polyester, which try to use it in the minimum possible, we do it on shoes, for example, or in parkas. Like if you look at the last Chloe show, there's like a parka poncho. You don't really put it in a washing machine. So it's products that you don't really put in the washing machine as per se. But yes, it's the microplastic, and there's a technique that if you're gonna put something that's polyester, you have to put it in a kind of a bag, Yeah. So that's number one. I'm in the sector of luxury that talks to a certain audience, but there's also an attraction from the youth that, aspiring luxury client. And it's the youth that you want to inform. But yes, that's when I say that we need another catalyst, like Fusion needs maybe another mainstream Hollywood celebrity from a big show that can bring it to the other level. I can bring it to this level, and then somebody else has to bring it to that level. So that's how it would have to work in my mind.
Would it be enough to put tags on the clothing as it's being sold in stores to really explain the connection between fusion or just to try to spread the word about fusion? Would that be enough? I mean, I'm wondering what you both think.
Well, we did that for the Fusion collection. We did pieces and some talk workshops on the stores.
I think like just generally like this also plays into the aspect of, there's many audiences in the world, and like finding the right person to speak to each audience is very important.
Yeah, I mean, I'll also add, as fusion physicists, communicators, right, to Alex's point, there's so many different folks who have no idea even that this laboratory exists, and they live just a few miles away.
Yeah, exactly.
Right. And so it's on each of us as scientists and as communicators to do our own communication as well, I think, right? And being able to reach audiences we normally wouldn't reach is a key piece of that. So thank you. There was a question over here.
Hello. My question is, have you reached out to religious leaders and all?
Have we reached to?
Religious leaders and all to communicate about fusion?
That's an interesting question. Not specifically, I haven't. So, mostly we try to reach people through events like this and going out to talk about fusion. Or we do something called Fusion Day on Capitol Hill, where we go and have many meetings with both members of Congress and their staff about it. Or I assume similar sort of thing, in the private sector, Commonwealth will as well make sure people get the word out. And so it is telling two friends who tell two friends who tell two friends. We just made a new friend.
We have in the past gone to church because somebody in the lab, for example,
Sure.
is part of a community, and it's always a new experience.
Yeah. So I just want to wrap up. I don't know if there's anything we haven't covered yet. Anything? No, but then I just want to say personally how thankful I am for your work, thankful for you coming here, thankful to all of you for coming to not just this lecture, but to everything. And if we could give just a big round of applause to Gabriela and to Alex.
Thanks for having us.
Yeah,
Thank
thank
you
you
for all the work you do.
Good to
Oh,
meet you.
and I see for those of us who still have our little slides, right? And want to see the colors, we have plasma ball, we have a hydrogen, I think it's hydrogen, spectral tube. Feel free to come on up, and thank you again. And we'll see you everybody next year.